Day 8. Today we will learn how to multiply and divide expressions that have fractional exponents in them. Example 1. Alright, problem number 1. If the bases are the same, you can do something with the exponents. If you're multiplying, we're talking about adding the exponents. So this would be 6 to the 1/2 plus 1/3 power. This ink is too thick. That's better. Alright, so off to the side someplace, let's talk about this. Since we will not have our TI-30 XS multi-view. So, if I want to add 1/2 plus 1/3, we need like denominators, so we could make these both into 6's. So I could multiply this by 3 in the top and bottom. That would make 6. And I could multiply this by 2 in the top and bottom, because that would make 6. So then this would become 3/6 plus 2/6. Alright, and when you add fractions with like denominators, you just add the numerator. So this would be 5/6. Okay, fantastic. So that's what is going to happen here. So that's why I will have 6 to the 5/6 power. And that's it for problem number 1. Number 2. On this problem, we see that the exponents are the same. On the last problem, the bases were the same. So if the bases are the same, you can add or do something with the exponents. If the exponents are the same, you can multiply or divide with the bases. Alright, so since the exponents are the same, I can go ahead and multiply 27 times 3. Now, 27 times 3 is 81. So this is going to become 81 to the 1/4 power. Okay, 81 to the 1/4 power. Now, all of this is still squared. Okay, so look, I have a choice. I can go ahead and this will simplify 81 to the 1/4 power. Or I could multiply by the 2 and simplify afterwards. Either way, I'll get the same answer. So let's do the inside part. Hopefully you have now learned that 81 to the 1/4 power is the same thing as the 4th root of 81. Okay, if we did that conversion. So 1/4 power, 4th root, same thing. The 4th root of 81, see 4th root 81 is 3. So this inside the parentheses here is really just 3. And 3 squared is 9. Alright, so that is the answer to number 2. Look, just to be complete, here's another way I could have done it. So I'll say or. Alright, I mean that's finished. I'm showing you an alternate reality. If I had wanted to, I could have gone ahead and multiplied the 2 times 1/4. So then I would have had 81 to the 2/4 power. You know what I mean? Because this would then be like 2/1. So it's 1 times 2 is 2, and 4 times 1 is 4. So I could have done that. Of course, 2/4 reduced down to 1/2. So this would have been the same as 81 to the 1/2 power. Now, hopefully you have learned that the 1/2 power is the same thing as square root. So we'd have, really this is the square root of 81, which again is 9. So either way you're going to get 9. That's it for number 2. So number 3. Let's see, number 3. See, this one I like. See how we have the same exponent? That's great. So if the exponents are the same, then we can go ahead and divide the bases. So that means what I'll have here, I'm still going to have the 1/4 power, but 18 divided by 9 is 2. So I have 2 to the 1/4 power. Okay? If the exponents are the same, you can divide. And then I still have this third power. Now a power to a power you multiply. So this would be 2 to the 3/4 power. Alright? Think of this as 3 over 1. So I have 1 times 3, 4 times 1, that's 3 over 4. Alright, so that is definitely the answer for number 3. See? Clean, neat, that's what a problem should look like. Much better than bad old number 2. Garbage. Asymmetrical garbage. So looking at problem number 4, these bases are the same. So if the bases are the same, you can definitely add the exponents together. Alright, if the bases are the same, you can always do something with the exponents. In this case, what you can do is add the exponents. So I'm talking about 1/4 plus 3/4. Feel free to do this step in your head. 1/4 plus 3/4, guess what? That's 4/4. But that's 1, which is just 3. So that would be the answer to number 4. Boom. Alright, number 5. Okay, check it out. The exponents are the same. If the exponents are the same, you can go ahead and multiply these bases. Okay, so 64 times 8. Okay, so 64 times 8 is 512. So I can go ahead and write 512 to the 1/3 power. Okay, because the powers are the same, I can go ahead and multiply. Alright, now I have 512 to the 1/3 power. Is this on the chart? Do I have a chart? I don't see a chart. I better go get a chart. Please stand by. So we have 512 to the 1/3 power. Now looking at the chart, if I want to do the 1/3 power, I start with the cubic column. I see 512 right here. So the cube root of 512 is 8. Excellent. So this is 8. So that means I have 8 inside the parentheses squared, so that is 64. Kabam. That's number 5. Alright, number 6. Loving it. We have the powers are the same, so therefore we can multiply the bases. So 3 times 6 is 18. So I will have 18 to the 3rd power. And then out here I still have negative 1/3 power. Now when you have a power to a power, you multiply. So this is going to be 18 to the negative 1 power. Whoa, Burton, where are you getting negative 1 from? Well, I'm glad you asked that. 3 times negative 1/3, this is, you can think of it as 3 over 1. Okay, so look, I'm doing 3 over 1 times negative 1 over 3.
Like, and you'd be like, shh, no. Just keep doing this. Keep doing this the whole time I'm doing this math. Except it'll take me even longer to do the math because I'm not good at procrastinating. Well, actually, I'm very good at procrastinating. I'm not good at multitasking. I can multitask, but not procrastinate. I mean, I can procrastinate, but not multitask. Same bad at speaking.
This is my daughter talking.
I'm talking so that you can't do your work. Because you make me do math and I don't want to. You can't make me do math. You're trying to do a crazy dad. What's wrong with you? It is 10 o'clock at night. This is not time to be doing math when this is not due tomorrow.
Hey, your mother sent you down here, so I would have you do some math. So
I did math, but now you're making me do more math.
One last problem, kid.
But I don't want to do it.
Say it right.
I don't want to do it.
That's better. Okay. So 3 times -1 would be -3. 1 times 3 is 3.
About having a recording.
So clearly, this is going to be -1. So this is 18 to the -1 power. And if you have a negative power, you're going to drop it down to the denominator. So this will be 1 over 18. Notice it's not -18, it's just 1 over 18. Wop, wop. So that's number 6.
Number 6.
Number 6. Let's play Smartball. So, on this one, the bases are the same. You might not see it, but there's an invisible exponent of 1 on this 4. So, since the bases are the same, we can go ahead and work with the exponents. So, in this case, we're going to subtract. So, this would be 1 minus 1/2. Okay? Now, off to the side, I'm going to do the 1 minus 1/2 effect. Sweetie, I gotta see. I gotta be able to do this. She was covering my eyes. 1 minus 1/2. I love to work with 1 when I'm doing fractions, because you can make 1 into anything you want. 2 over 2, 3 over 3, 4 over 4, whatever you want. So let's make it 2 over 2. So that way I can do it. So they're like denominators. So 2 minus 1 is 1. So that will be 1/2. So that's what's happening here. Okay? So this is going to just be 4 to the 1/2 power. Oh look, 4 to the 1/2 power. We've memorized that 1/2 power is the same thing as square root. So this is really the square root of 4, which is 2. So your final answer should be 2. Okay. Ocho, baby, ocho. Oh, this is practically the same thing. This is 8 to the 1 power. So once again, I can, since the bases are the same, I can do the exponents, subtract. So this will be 1 minus 3/4. Alright, so off to the side, okay, looking at this, I've got 1 minus 3/4. Since I wanted denominator 4, let's replace 1 with 4 over 4. So I have 4 over 4 minus 3 over 4. 4 minus 3 is 1, so that's 1/4. So this will become 8. Wait, I didn't want to use green just then. OCD!
It's CDO.
Really?
Yeah.
Maybe in Spanish.
No, they've got to be in alphabetical order.
I get it, because it's OCD. So
It's CDO.
I totally get it. I'm so smart. We're smart together. But I'm experiencing technical difficulties. I'm trying to select blue. Alright, I better pause the video. It's not working. So this is going to be 8 to the 1/4 power. Because that's what's happening.
Yeah.
So that is the final answer. Alright, number 9. Love it. The exponents are the same, like,
Mr. Burton, I have a question.
yes, darling. So, 54 divided by 27. Something tells me that is 2. Bam! Look at that. Deuce. So if the powers are the same, I can do the division. So this is going to give me 2 to the 1/4 power, and then that whole thing is squared. A power raised to a power you multiply. So this will give me 2 to the 2/4 power. Alright, 1 times 2 is 2, 4 times 1 is 4, so 2/4. And then just reduce this, so I have 2 to the 1/2 power. And that is it for that problem. Let's see. Okay. So on this problem, we've got some multiplying to do. I have 3 times -4, so clearly that's going to be -12. Now, when I go to multiply the a's, of course, when you have the like bases, you add the exponents. So what I'm doing here is 1/5 plus 1/3. So off to the side someplace, I'm going to do this. So 1/5 plus 1/3. To make those denominators the same, perhaps we multiply by 3 here. And how about if we multiply by 5 here? Let's see what happens. Well, that's going to give us 3/15 plus 5/15. So that is going to be 8/15. Alright, that is how you add those fractions. So that is why the answer to this question will become -12a to the 8/15 power. Alright, that's it for number 10. I feel like I should put a box around it. Alright, number 11. Alright, there's really nothing to do on the inside. So I'm going to go ahead and do this 2 the second power to everything. Now if I do -2 to the second power, that is going to be +4. Alright, I've got -2 squared. Now for these variables, a power to a power, you multiply. So this is going to give me x to the -2/3 power and y to the 1 power, which is just y. Now look, as far as the -2/3, I did -1/3 times 2, right? That's 2/1. -1 times 2 is -2. 3 times 1 is 3. So that's where the -2/3 came from. And over here when I did the y, I saw that I have 1/2. So 1/2 times 2, alright, again this is like 2/1. So 1 times 2 is 2. 2 times 1 is 2. 2/2 is 1. So that's why I put y to the 1 power, but we don't need the 1, so I just put y. So that is where all these things came from. The only thing I would change about this is I have one expression here that has a negative exponent on it. So when you have a negative exponent, you're on the wrong side of the fraction. So here's the invisible fraction. This must drop below. So that is why I'm going to have 4y over x to the 2/3 power. That had to drop down. So this is the final answer for number 11. Okay, let's take a look at number 12. Alright. Well, the exponents are the same, so I could divide the bases, except for their variables, so can't really do anything with that. But so I will just go ahead and multiply when you do a power to a power, you multiply. So if I do 3/4 times 5, remember this is 5 over 1, so 3 times 5 is 15, 4 times 1 is 4, so this is 15 over 4. So this will become c to the 15 over 4 power over d to the 15 over 4 power. I don't really see anything else we can do with that, so I'm going to declare this the final answer. Alright, normally I would divide the c and the d, but they're just variables, so what are you going to do? Alright, on to number 13. Now here, the bases are the same. If the bases are the same, I can, in this case, subtract the exponents. Now remember, this h is like h to the 1 power, so I'm going to be doing h to the 1 minus 4 over 3 power. So off to the side, I'm going to do this 1 minus 4 over 3 business. So if I have 1 minus 4 over 3, again, I love 1 because I can make that into any fraction, anything over itself. So I could make this into, for example, 3 over 3 is 1. I chose 3 over 3, so I would have a like denominator of 3. So 3 minus 4 is negative 1. So that gives me negative 1 over 3. So this is going to be my exponent. So I'm going to have h to the negative 1 over 3 power. Alright, so there, that came from this calculation. But since it has a negative exponent, I am going to drop it down to the denominator. Anything with a negative exponent is on the wrong side of the fraction. So there's an invisible fraction right here. This has got to drop down. So that's why in the end I will have 1 over h to the 1/3 power. Alright, so that is it for number 13. Okay, how about number 14? Let's see. Well, inside of here, I've got the 2 and the 3 at least. Alright, so 2 times 3 is 6. So I've got 6 a to the 1/5 power, b to the 2/5 power, all to the 4th power. Now, the bases aren't the same because I have a and b, and the exponents aren't the same either. So I'm just going to go ahead and do this 4th power to everything. So 6 to the 4th power, I'm going to need my table for that. Whoops. Okay, so I've got 6 to the 4th power, see, 4th power, is 1,296. So I will have 1,296 a. Now here I'm going to multiply. 1/5 times 4 is 4/5. Alright, because I'm doing 4 over 1, so 1 times 4 is 4, 5 times 1 is 5. And then similarly I'll have b to the 8/5. And there's really nothing more we can do with that. So that is your final answer. Alright, how about number 15? Okay, the exponents are the same, so if these weren't variables, I could multiply the v times the z. But since there's variables, there's really nothing I could do with that. So I'm going to go ahead and multiply these exponents by -2/5. Now look, 5 times -2/5. If you keep in mind that 5 is really like 5 over 1, then, now me personally, I would just cancel these out. So I know the answer is going to be -2. But, okay, say if you didn't realize about canceling out the 5s ahead of time. then you would have said 5 times negative 2, that's negative 10. 1 times 5 is 5. Then you would have divided, and you would have gotten negative 2. So when I do negative 2/5 times these two 5s, I'm going to get v to the negative 2 power, because of this calculation. And I'm going to get z to the negative 2 power. Now, both of these things have negative exponents. So that means that they are both on the wrong side of this invisible fraction line. So they're both going to have to drop down. Okay, so in the end, I will have 1 over v squared z squared. So that would be the answer to number 15. Now, for number 16, the bases are the same, so I can subtract the exponents. Remember, this is an invisible exponent of 1. So I'm doing n to the 1, and I'm going to wind up having 1 plus 7 over 9. Alright, because I have to do 1 minus negative 7 over 9. But you understand, if I have 1 minus negative 7 over 9, minus and negative is addition. So that's the same thing as 1 plus 7 over 9. Okay? So continuing on to do this calculation. Remember, I can change this 1 into anything over itself. So looking at that 9, I'm going to turn this 1 into 9 over 9, because that's the same as 1. So I have 9 over 9 plus 7 over 9. Okay, but that's 16 over 9. Okay. Alright, in the past I've been doing this in green, so I'm going to go with that. Alright, so I've got 16 over 9. So that's what's happening right here. So I should have n to the 16 over 9 power. And I got that from doing all of this. So that's the final answer for number 16. Okay, number 17. The exponents are the same, so if these weren't variables, I would go ahead and divide them. But since they are variables, I can't do anything with that. So I'm going to go ahead and multiply everything by 2/3. So look, off to the side, please understand that if I'm going to do 2/3 times 9, this is really like 9 over 1. Alright, now I would cancel the 3 into the 9. That would be 3. 2 times 3 is 6. So I know the answer is going to be 6 because I'm a genius. But if you're not on my level, then you're going to do this. 2 times 9 is 18. 3 times 1 is 3. And then 18 divided by 3 is 6. Okay, so that's what you get whenever you do 2/3 times 9. So that's what's happening in both places. So that's why I'm going to wind up with e to the 6th power over f to the 6th power. Okay, so please understand that these 6's are coming from this calculation. Alright, but anyway, that's the final answer for number 17. Alright, number 18. Okay, anything I can do in here? Not really. So I'm going to go ahead and do this negative 1/5 power to everything. So look, for a brief moment, I'm going to have 32 to the negative 1/5 power. Okay, I'm just going to leave it like that for a second. Now I'm going to have x to the, now I'm multiplying. A power to a power, you multiply. So negative 3 times negative 1/5. That'll be a positive. A negative times negative is a positive, 3/5. Okay, because this is like 3 over 1. So 3 times 1 is 3, 1 times 5 is 5. Now I'm going to have y to the negative 3 power. Where'd that negative 3 come from? Well, I'm glad you asked that. Okay, look at this. When I did this right here, okay, I'm doing 15 times negative 1 over 5. Okay, so this is really like 15 over 1. So that made negative 15 over 5. Just 15 times negative 1 is negative 15. 1 times 5 is 5. Negative 15 divided by 5 is negative 3. So that's where the negative 3 came from. Now, anything with a negative exponent is going to move to the other side of the invisible fraction. So this has a negative exponent, and this has a negative exponent. And here is the invisible fraction. So both of these have to drop down. Okay, so that is going to leave me with, alright, in the numerator I will have x to the 3/5 power. In the denominator I have 32 to the 1/5 power, and y to the 3rd power. Now the only thing left to do is to evaluate 32 to the 1/5 power. Now I'm hoping you remember that 32 to the 1/5 power is the same thing as the 5th root of 32. It's the same thing as 5th root of 32. So let's look at the table for the 5th root of 32. Okay, 5th root of 32 is 2. Okay, so that's why this entire thing is just 2. Alright, so that's why the final answer is going to be it's going to be x to the 3/5 power over 2 y to the 3rd power. And that will be the final answer. Alright, and I believe that is the last problem on this particular worksheet as well. Alright, I hope that was helpful, and I will see you on the next video.